Let's look at subtracting a one-digit number from a two-digit number. Let's first look at 7 minus 5. Most students, as they come to second grade, will know their basic fact of 7 minus 5. 7 minus 5 is 2. So if they have 17 minus 5, they can take their 5 from the 7 ones and leave this 10 stick, the 10, alone, and they subtract 7 minus 5 and keep their 10, leaving them with 12. The same would hold true, obviously, for 27 minus 5, where students, they don't touch that 20 at all. They're able to take 5 from 7 and be left with 22. Now let's say they had 34. With the problem 34, if they were going to take away 3, again they have enough ones. They can take 4, they can take their 3 from the 4. 4 minus 3 is 1, and they have 31. Many students can do this work in their head, and the recordings here just help us to see what it is that what we have as we work in the parts. Now let's say we have 31, and we want to take away 9. We don't have enough ones to just take our 9 ones from this 1. And this is where using the making 10 strategy, or taking from 10 in this case, really makes a difference. Students will naturally, if they have the linking cubes, see that they can take 9 from a 10 really easily. How many do they have? Well, we take away the 9, and they see that they have 21 that they never touched, and they took the 10 to subtract 9, so that they now have 22. 21 plus their extra 1 equals 22. This steps, the recording method, makes it look more cumbersome, but when you just see the linking cubes, you can see why this is a really great mental math strategy. Let's try another one. Let's just do it with cubes first. Right now we have 41. 41 minus 9. I'm going to take out 9 from here. How much do I have left? Just looking at it, you can see 32. Well, how did I do that? Well, I picked up a 10 stick, and that's where I took my 9 from, and that left 31 cubes in their place. So I ended up adding 31 plus 1, because I had 10 minus 9 equaled 1, and then 31 plus 1 equals 32. Let's try one more, a little harder. What if I had 45 minus 8? My basic fact doesn't help me here, so let me think about where I can take the 8 from. I pull out a 10. So if I wanted to just answer this, I see that I have 35, and I took out this 8, so I have 35 plus 2 is 37. Because I did 10 minus 8 equals 2, and then added that back. I'll do one more silently so you can try and figure it out. And this is helpful because if we had 45 minus 8, you could take out 15, so that you do 15 minus 8. That's how we do it in our standard algorithm. But at this point in the year, many students don't know their basic fact of 15 minus 8 off the top of their head. But they do know their basic fact of 10 minus 8 off the top of their head. So what we're doing, if I wanted to compare it to your basic algorithm, is we are, instead of making this 15, we're making it 10 and taking our 8 from the 10 so that we end up being left with 2 instead of taking it from the 5. And then we're adding 2 plus 5, which again is a basic fact they know, to find 37. So we really are working directly in line with the algorithm that we eventually will work with the students. But in the meantime, where they don't know their basic facts at a quick, efficient mental level with fluency, we're giving them another way, another strategy that uses all of their fluency to solve the problem. So let's just do one more. And this time, I'll put the problem up. Trying to decide what to do for you. Make it a little bit more challenging. Let's do 34 minus 6. I can't take 6 ones from these 4 ones, so think about that. So I took out my 10. I took away 6 from the 10 because I know that quickly. That's 4 left. And I didn't touch 24. So 24 plus the 4 equals 28. And this is the reason, or part of the reason, that asking students in first grade to know 10 more and 10 less mentally can really make a difference, because many of the students can then look at a problem and do it right in their head. Thanks for watching. If you have any questions, as always, please just email me.